Okay, we have a product rule. So when two things are together with multiplication, that's what product means, multiplication, we can separate them with adding. So do you see how x and y are in there with multiplying? So I split them into two separate logs by separating them with add. If two things are connected with division, I split them into two separate logs with subtraction. If I have an exponent, a power, I'm going to make it a coefficient and multiply it. Okay? It kind of makes sense with exponents, because do you remember this from your past? Okay, what did you do with the exponents? You added them. If this was dividing, what did you do with the exponents? Subtracted them. If this was a power, what did you do with the exponents? Multiplied them. Is that not just the exact same thing as the log rules, right? Okay, it's the exact same thing. So multiply changes to add, division, subtract, exponents, multiply. Okay, so I'm going to separate this into how many different units do you know are going to come out of this at the end? There will be 3. 1, 2, 3. There's going to be 3 different units. Okay, so here's what it looks like. 3 log ax, because I took the exponent and changed it to a multiply, plus log a y, and then there's a division, so subtract 2 log a z. Okay? Okay, next one. How many split apart units will there be here? There's going to be 4. There's going to be 4 different units when I'm done. Okay, what is a different way for me to think about the square root of x? I want to think about it differently. It's x to the half. Okay, so I'm going to go 1/2 log 5x plus log 5y minus log 4 and then I'm also going to be minusing 6 log 5z. Okay, some people mistakenly add that because they're thinking, well, that was multiplied by that, which would be me doing, I'm dividing a multiplication, which causes 2 subtractions. So basically just think, if it's on the top, positive, if it's on the bottom, it's a divider. Okay, how many different separate units am I going to have on this one? This can't be separated. There's no multiplication to separate it. It's just a unit. Okay? I get that a lot. People try to separate that as a log 7x plus a log 7(2). You cannot separate that. There's no rule. This can separate from that because it was a multiplied by, and this will have to be its own unit. Okay, do you see how I'm understanding that? You can only separate stuff if it's a multiply or a divide. So it's going to look like this. Log 7 of bracket x plus 2, because it's a unit that I can't separate, minus log 7 4 minus 6 log 7 of the unit y minus 1. Okay, express as a single, so we're going to work backwards. This was expanded and we're going to get it back together. So log 7 of a bunch of stuff. Okay, so this, to put it back together, I'm going to move the multiplier back to an exponent, so m squared. It was separated with an add, so therefore it was attached with a multiply. This is a subtract, therefore it's a divider, y to the 4th. This is a minus, so it will be on the bottom, x cubed. Okay, so that is those 3 rules: product, quotient, and a power rule. Okay, evaluate. Let's do some labeling. So that is a base. That is an exponent. Okay, I know it's confusing because there's a log, but the log is in the exponent. That whole thing is the exponent. Do you see it? And it will equal some results. I'm just going to put a question mark there because I don't know. Okay, right now, what format am I in? Am I in an exponential form or am I in a log form? This is a exponential expression right now. Base to an exponent. That's an exponential. Can you change it to a log form? So how do we write log? Log. Can you put the base here? So 8. The results equals exponent. And is there a conclusion you can make now? What is the result? 70. Okay, if this is log 8 something, log 8 70, therefore we're concluding that that has to be 70. Did you notice how I didn't write x equals or anything like that? Because I don't want to add a variable that's not there unless I let x equal. If I state that, I can work with that. Okay, but if you don't state it, don't add x's or else you get deducted. Okay, same thing. Let's label some stuff. So this would be a base. This up top is the exponent. And it would equal a result. Okay, my understanding is the format is exponential. So I'm going to switch it to a log form. So do we understand again? Log base results equals exponent, right? That's what we're always going with. So log 4 question mark equals 3 log 4, 5. Okay. Now what I want to do is I want to change this using my rules that I just learned. So log 4 of question mark would equal log 4 of 5 cubed. Therefore, where my question mark is would have to be a 125. Okay, so we really have to understand those forms. If you don't have them somewhere, you make sure okay? That's the basics to a lot of this stuff, so make sure you have that memorized. Exponential looks like this. Base to an exponent equals a result. Log is log base result equals exponent. Okay? That's to be memorized. That's a key. Okay, let's try some of these. Okay. How do I get a 20? I'm allowed to use the number 4, 5, 8. I'm allowed to use multiplying, dividing, and exponents. So how can I get to 20 using a 4, a 5, or an 8, and I can only multiply something, divide something, or exponent something? Do you have a combo that can get me 20? 4 times 5 is the same thing as a 20, right? Okay, now the rules. If these two things are multiplied, I can separate them into 2 logs with adding. And then it told me the log A4 was 3.419. And I'm okay if you just don't type on your calculator and save yourself some time. I'll do it. 7.388. Okay. 16. How can I get a 16? I'm allowed to use a 4, a 5, and 8, multiply something, I can divide something, or I can use exponents. How would I get a 16 out of something?
4 times 4.
4 times 4, or can I do 4 squared? Both will work. Okay, using the rules, how do I change the rules? If this is a power, it will now get to be a multiplier. Okay, and then I fill in log A4 because I know that decimal number. Okay, log A 1.6. I need something to give me a 1.6. Anybody figure out what combination would do that? 8 divided by 5 is 1.6. Okay, once I figured that out, now I can separate with subtraction. Okay, the last one is a 10, which is a little bit more challenging to get, which is something I have on your test. How do I get a 10? You got to think of a combo. I can only use a 4, a 5, and 8 somehow. I'm allowed to use multiply, divides, and exponents.
8 times 5 divided by 4.
8 times 5 divided by 4. Yes. It's not the one I'm thinking of, though.
5 is 40, and then divide that by 4 is 10.
Yes.
That works, but I'm going to do a more complicated one, because that one's... Anybody think of a different one?
5 divided by 4 times 8. That's right.
Okay, here's what I want to do. I want to do 5 times... What do I have to times it by to get to 10? 2. Where could I get a 2 from?
8 divided by 4.
Oh, split 4.
I want to do this because it's a little bit more complicated. But yes, yours would work, but I want to do this because it's more similar to your test. Okay, does that work? Because I can use exponents. Is the square root of something an exponent?
Yep.
Yes. Okay, so I'm going to go like this. Log A5 plus, and then how do you change the square root of something? A half log A4, right? Because the square root is the same as writing something to the half. Okay, we got to get comfortable with that. You use that quite a bit. Okay, and then the final answer would just be placing the decimals in there. Do you want to put a star in that question? Because I feel like sometimes that question on the test tricks people because they just can't find their combo. Okay? Okay. Some weird evaluation questions. Okay. I'm going to evaluate. So this is what my brain says. What's the exponent that makes this happen? So if there was a base of 4, what's the exponent that makes that happen? We should have these memorized. We get a 3. So that's a 3. Okay. I'm going to evaluate this log expression. So if the base was 4, my brain is saying, what's the exponent? How do you get to 2? 4 to the half. Okay, and without our calculator, what do we do with 3 divided by half? What does it turn into? 6. Because it's the same math as timesing by 2. Okay. So when you work with this one, you have to evaluate that first. So my brain is going to go 2 to the something would give me 16. The base of 2 to some exponent. What's the exponent on that one? 4. Okay, now I have a new log expression. So what my brain is going to do is the base 16, some exponent, result 4. And that would be the same as a square root of 16, so it's a half. Okay, next. I'm going to rewrite this because I have a rule. I don't like that 2 in the front. Okay, so that was me rewriting because I recognized a rule. And then I'm going to just change 8 squared. Okay, I need to do this evaluation first. Okay, so what's your brain going to say? I need 4 to something that will make a 64. So 4 to the, what exponent would you need there?
3.
3. Okay, so that turns into a 3. Now I have a new expression, so my brain's going to go, the base of 9 to something gives me a 3. Square rooting the 9, so therefore the exponent is a half. Okay, last question. Can you tie that together for me? So there was a split add and then there was a subtract. Can you put that back together with multiplies and divides? Okay, is that what you had for the rules? Times, and then there was one divide. Because the add goes with timesing, the subtract goes with the divide. Okay, what is 36 times 24 divided by 4? 216. So now I need to figure this out. So I'm going to go 6 to some exponent produces 216. That's what I'm thinking of. And then that exponent is 3. Okay? Please remember when you're evaluating log expressions, boom, I just want a 3. I don't want 6 cubed written. It's just you're answering what is the exponent. That's what your answer is. What is the exponent? Okay? Don't write 6 cubed, just 3.